All right, let's do a problem. Let's continue doing these ones. I just realized Advent of Code has been going on. Actually, I forgot about this thing. I did it last year, like a little bit with Go. It's kind of a pain, to be honest. This is 2025 though. Oh yeah, this is 25. So day 1, day 2, actually it's done. Maybe I can go through it. We'll do that next time, but maybe when my finals are done. But anyways, the split array largest sum given an integer array nums and an integer k, split nums into k non-empty subarrays such that the largest sum of any subarray is minimized. Return the minimized largest sum of the split. A subarray is a contiguous part of the array. Okay. Okay. There are 4 ways to split nums into 2 subarrays. The best way is to split it into where the subarray is only 18. So is that okay? So is that saying 9? So that's 9, 14. Okay, what? There are 4 ways to split into 2 subarrays. The best way is to split it into 7, 2, 5, and where the largest sum among the 2 subarrays is only 18. Split nums into k non-empty subarrays such that the largest of the sum of any subarray is minimized. What is return the minimized largest sum of the split? Okay, let's see. There are 4 ways to split it into 2 subarrays, and the best way to split it is 1, 2, 3, and 4, 5, where this largest sum among the 2 is only 9. Only 9? What is this compared to? Okay, there's 2 problems I need to figure out. Okay, is basically from nums and k, figure out how to split the array and pick the best one. I don't know what the best means here. So, okay, for example, here nums we have here is, let's do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? So we could do 1, 2, 3, 4, right? That's 1, right? Then we could do another way, which is, actually, let's put that back. We could do the opposite. We can do like this. 2, 3, 4, right? Another way is, okay, all possible splits, right? Where k equals 2, right? Then we can do 1, 2, and then we could do 3, 4, 5. We could do 1, 2, 2, 3, and 4, 5. Right. So already off the bat, I don't understand what there are 4 is split into 2. Right? Is this not? Wait, this is not right. There's 1, 2, 3, 4. Oh, okay, I see. Actually, this would probably come about from here. I can probably get this as well, like 1, 2, or it's like 1, 2, and then 3. Oh, okay. I think I got all of it. These are all the possible 4 ways, right? And they're kind of analogous here. Like I can take the last 2 here, And then these two, yeah, these are the only 4 ways you can split nums into k. You can all possible splits where k equals 2. K splits of nums. All possible k splits of nums. And then we take the max of the sum of array 1, array 2, which equals, well, that's going to be whatever, 1, 2, 3, 4, 5. That's going to be 3, 6, 10, so 10. So it's basically saying 10, 5, which is just 10. We have here max of right. We'll take that. So max. That's 9. Max 1, 2, 1, 2, 3, 4, 5. 2 plus 3 plus 4 plus 5. Two plus 3 plus 4. Okay, 2 plus 3. That is wait, hold on, what am I doing? That's 1, and we're saying this is 5, 9, so 19. Max here is 6 and 9. Where the largest of the 2 subarrays is only 9. So 1, 2, 3, 4. Okay, what is this saying here? So we're saying max of 3, and this is 7, 12, which will equal 12. That's my understanding of it, but I don't know why we picked 9. Like, I see the answer 9 here, but what made 9? Because it was the smallest? Okay. Okay. First things first, how the hell does binary search relate to this? No freaking clue. But okay. Already off the bat, brute force. Figure out split array into k, k different split nums into k subarrays. Take the max sum of either of the split. Keep track of the smallest. Return the smallest. So that is brute force, but that's terrible because, bro, if k was like, k could be freaking at most 50 to the entire array, and an array could be at most 1,000. So actually, brute force might work. Brute force is possible, but let's see how binary search would work. So binary search has something to do with has something to do with the order and sorted properties. So I can't sort them because they're subarrays, meaning there are contiguous parts. So yeah. So how does binary search relate to this? I don't know. How can we do this? Okay. I do have an idea. Here's this. So we have an array here. 1, 2, 3, 4, 5, right? Then we can take a pivot point, which is k, right? We'll take from here, right? We'll say, okay, like this, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 1, 2, 3, and like that, right? And then we'll do that, and then like this. Okay, brute force split k into subarrays, take max out of the split, keep track of the smallest, return the smallest. That makes sense. But the problem is, how do we do binary search? Binary search, this, okay, the thing is, it looks pretty small. Like the constraints. I think the idea is to, okay. We can say, let's say like LR is gonna be, what is the smallest that the, I guess, sum can be? Probably the biggest number, right? Which was, I think, 10, right? So we could do the max of the nums, then the largest number you can probably do is probably the whole array. It doesn't count, but like the k isn't a constraint here. K isn't a constraint here, but it does count as, because like, okay, if I take the whole array, I mean, that's a good ending point to say. Obviously, there's going to be numbers smaller than R. So we can definitely say that's our, like the sum of nums. Right? And then basically, just calculate the middle and then try it. Can you make numbers and split them in such of at least k size that are less than or equal to this less than or equal to this like midpoint, right? Midpoint, mid-sum right here, right? L plus R divided by 2, right? And then basically count it, and then so we'll have like a function, or we'll just write it out, like build out thing. We'll build out the like we'll do okay. So we'll, for every n in nums, we'll count how many subarrays we can make that are, I guess, less than or equal to this midsum. If it's too big, or if you can split it, that's potentially one. If you can't split it, meaning like we can't make any more subarrays, then that's we skip it. But we probably will move up L, because that was way too small. So we want to move up. So yeah. Okay, let's try that. So let's do, so we have L, R, max of nums, and sum of nums. I think we did this pattern last time, like last problem. We had like the, like this kind of search space being the smallest, the biggest being like obviously the biggest numbers to obviously all the numbers. So, okay, so we'll do this. While L less than equal to R, middle, we'll say L plus R 2. Okay, then here we'll do the complicated thing here. So we'll do sub arrays. We'll just have a counter, and then we'll do for every n, and we'll do a cur sum for every n in curse, for every n nums, cur sum plus equals n. It's like the pattern last time. Okay, so we'll do if the cur sum is greater than m, right? Oh, no. If it's greater than or equal to m, then that is a subarray. That's one subarray, so we'll count that subarray, right? That's one subarray, and then we need to reset the cur sum. So cur sum, I think we could reset it, right? Do I reset it? No. We set it to n, because, like, for example, let's say our thing was 18, right? I'll add, and then this will be 9, 14. And when I try to add 10, that exceeds it, right? So I'm going to set it to 10 and then count this as 1. And then that was 10, that's already 1, and 8. But I actually, then that's 18, and then plus, we actually don't. Ooh, shit. Wait, hold on. So that's 1. Actually, I only care if it's greater than m, and then I would have to plus 1 it. Right here, plus 1. So subarrays, one more, right? Then we check if subarrays equals the k, that is a valid solution. So res equals the midpoint, and then we could potentially okay, not mid, actually, yeah, and then potentially we could potentially get greedier and try to find something smaller. Otherwise, that was way too big, so it's not possible, so we should increment. So it's mid plus 1. No. Yeah, mid plus 1. And then return the res. I think that works. Let's try it. Ooh, come on. Okay, never mind. Oh. Ooh, res. I'm gonna say R. I'm gonna say R. No, it doesn't work. Oh, wait. If subarrays are equal to k. Okay, that's fine. Oh, no. If it's less than or equal to k. Because if we don't use all of them, that's still potentially 1, though. You know? Boom. Let's go, bro. All right. See you guys tomorrow.